Alright, so we're looking at problem number 2 here, the one with Robin Hood. First thing it asks us to do is to sketch a diagram of what the problem is describing. So we get some ground, because he's shooting from the ground, because it says that he's standing on the ground. And here he is, kind of lean back when he's shooting it up in the air. Let's see here. Kind of like a bow like this. Pulling it back. So maybe it gets like this. Pulling the bow. The other arm is holding onto the arrow, or the bow itself. And he's got his head and a little hat. That's nice. Alright, so there's our Robin Hood. And he shoots the arrow and it launches up. Here's the arrow now in flight. And it comes down, hits the ground. Alright. So, it's asking us a few questions. What's the maximum height of the arrow? How long does it take for the arrow to reach the maximum height? And when will the arrow reach the ground? We can use our calculator to figure that out, just like we did in class today. So, I'm going to plug it into my calculator. Negative 16 x squared plus 45x. Alright, so I use x instead of t because that's all I have. Right? I mean, there's a capital T here, but that's something a little bit different that we aren't going to be working with. We're going to use the x for our variable. Okay, so let's zoom standard. I usually like to start out that way so it always looks the same. And I see part of the graph, that's nice, but I don't see it all. So what I want to do is I want to get up a little bit higher, okay? So I want to move the graph up here somewhere. So what I'm going to do is, the only ones I'm usually messing with are going to be my x max and y max. Sometimes I mess with the y min just to get a little bit better view, but I'm mainly focused, remember, on this quadrant up here, the first quadrant. Alright? So, in this case I want to get to be a little bit higher up, so I'm going to change the y max. I'm just going to go to 50 and see what that does. Alright, and it happens to be high enough. So I can see the max, I can see the highest point. Alright, I can see where it hits the ground. I'm going to actually give myself a little bit more room down there so you guys can see what's going on a little better, because usually your calculator has a little bit of writing down here and it can get in the way. So, starts here at the origin, lands over here. Now it looks like it's pretty close to 3, but not exactly. So we're going to have to deal with that. So what's the maximum height? We're going to hit second, calc, go to maximum, hit enter, and I want to do my left bound. So I hit enter, go over to my right side, hit enter, and guess up at the top, and I get 1.4 for my x, or 1.41, and 31.64 for my y. So I'm going to write that down. Let's see here, my max is 1.41 rounded, and let's see here, 31.64. So that's my ordered pair. Well, my maximum height, we're talking about how high it goes up. So when we look at like an xy coordinate plane, we know we're talking about the y-axis. So that's my y right here. So my y would be 31.64 in this case. Feet, I think, are the units. Alright, I don't think it says. Well, we'll go with feet. How long does it take for the arrow to reach the maximum height? Well, remember, t is time, and we're representing that with x. We're plugging x in instead of t, because that's what our calculator has. So this 1.4 or 41 is going to be our amount of seconds. So 1.41 seconds. All right. And lastly, when will the arrow hit the ground? Well, we haven't figured that out yet. So let's come back to our calculator. It hits the ground right here. And we talked about in class how that's also a 0. So when I calculate that, I'm going to use, once again I did the second calc, and I have 0 right there for my option, so I click that one. And it says left bound, and it'll do the same prompts as usual. Well, my left bound in this case is up here, because if I'm going from left to right on the graph, this is the left, and then down here is more to the right. As you can see, your graph is slightly angled in this direction. So that way, you know, this is slightly to the left, this is slightly to the right. So I hit enter. Hit enter again. You'll notice that your arrows are pointing in towards each other. Okay? And then I hit enter when I'm close, and it gives me 2.81. So 2.81. That's how many seconds it takes for the arrow to hit the ground. All right? And that's about it.